Here we have a steel pipe with the outer and inner diameters given. It supports a concentrated load. The span length is 3 feet. So here determine the magnitude of the maximum bending stress in this pipe. Okay, then in this example, we're determining the global maximum values of the bending stress. So it's not a specific point as in example 1. Okay, so this will be a very typical example for our algorithm to practice our algorithms, the 3 steps. Okay, but in the final step, we will just calculate the maximum bending stress. That will be just the maximum bending moment times c over I. Right? The c and I can be calculated. Right? The c is a simple cross section again. It's a circle. Right? The centroid is just at the center. So the c maximum c to the top will be just c top. Then c bottom. They will be both equal to the radius, the outer radius, right? And the I can be calculated. So we'll just need to find where is the maximum bending moment. Where we have bending moment, the maximum bending moment, we need to find it out from the shear and moment diagram, directly moment diagram. Okay, so here in this example, the cantilever is shown here, but since we normally like to analyze everything from the left end to the right end, so we just simplify it into a 2-dimensional case and turn it over. Right? We will start from the left end, that is the fixed end. Right? We just turn it over, as shown here. We use this figure for analysis. Okay, step 1, we start from free body diagram, and to analyze the reactant forces and the internal forces. Right? So at the left end, here we have AX, AY, and M. Right? So the steps of analysis will be exactly the same as example 1. So here we have AX equals 0 and AY equals P. That is 1,200 pounds. Then the M will be negative P times L. Right, that is negative 1,200 pounds times 3 feet, but we need inch, right, times 12 inch. That is negative 43,200 pounds inch. Okay, then the V diagram, again, it will be exactly the same as example 1. Okay, the V diagram is here. So it's a constant shear force that will be just 1,200 pounds. Right, then the moment diagram, value at the left end will be negative 43,200 pound inch. Right, then from here to the right end will be a straight line to connect it. This is our moment diagram. Okay, so where is our maximum bending moment? That will be here, right, at the left end, or just here at the fixed point, right? So this is the maximum bending moment, and the value is negative 23,200 pound inch. And the C C top equals C bottom. Right, this will be just 4.5 over 2, 2.25 inch. And the I values will be, this is a circle, so we have the equations for this kind of simple cross sections. It will be just a pi over 64 outer diameter to the fourth minus inner diameter to the fourth. Right, so this will be pi over 64 times 4.5 to the fourth minus 3.5 to the fourth. Then we'll get 12.76 inch to the fourth. And the last step, we just estimate or evaluate the maximum stress on top. Right, so that will be maximum bending moment times C top over I. And so it will be 43,200 times 2.25 over 12.76. Okay, this will be 7,618 psi. Okay, you see that I ignored the sign here, right? I didn't use the sign here because carrying signs will make it confusing. Okay, so in calculating these bending stresses, we do not take the negative signs of bending moments. Right? We just calculate the result and then make our judgment. You can do your judgment to determine if this stress is positive or negative. Okay, in this case, is the value in compression or in tension? Compression or tension? On the top, okay, since you are adding this P downward, so its deflection will be in this way. So this will be crying, so on the top, it will be stretched. It will be stretched, that will be in tension. So how about maximum stress on the bottom? Okay, equation will be the same, calculation will be the same. That will be the same result. But the sign, this will be in compression.